Okay, so that all said, let's take a look at this problem and see what we got. So it says in the figure above, we've got f prime. So immediately, first thing you see is, all right, I've got the graph of the derivative. That should sound familiar. We've done lots of work with that. It says it's the derivative of the twice differentiable function, yada, yada. That's all math gibberish, all math jargon. And it's from -3 to 4. We could see that. Okay, so I just kind of skip down to the first question right now if I'm you guys. Don't get caught up in all the reading. We'll come back to it. Part A, find all the x coordinates at which f has a relative max. We have the graph of the derivative. So tell me, where is there a relative max at?
-2.
How did we know that? Why?
Because it comes from an increasing to decreasing.
All right, so there's a relative max, because we got to get full credit here now. A relative max at x equals -2 because, what's my because? Because what?
The function is...
So not the function, but f prime of x as our function, because f prime of x changes from what to what?
Positive to negative.
Perfect, from positive to negative. Okay, now just so you guys know, that's a 2-point question. The first part is for the answer. The second part is for the justification. So remember, we worked on that earlier in the year. It's a relative max at x equals -2 because f prime of x changes from positive to negative. Does anybody have any questions on that? Okay, all right, part B. What do we got for part B? On what open intervals contained in -3 to 4 is the graph of f both concave down and decreasing? What do we know if it's decreasing? That cuts the graph in half. Hopefully we know that if it's decreasing, it's going to cut the graph in half. And the half I'm interested in is now the half, that's a little crooked, so we can't do it correctly, but it's the half under the x-axis, right? So it's the half underneath the x. And then concave down on our derivative slope, our derivative graph is going to be a negative slope. So somebody tell me what intervals does this?
-2, -3 to 1.
Now -3 is above. Is that going to be decreasing?
Yeah, -2 to 1, and then from -2 to 4.
Well, hold on here. So -2 to 4, it's decreasing with you there. But now we also want and concave down. So concave down is a negative slope.
So from 1 to 4.
1 to, well, is it a positive slope from 3 to 4?
No, there's
Okay, so we want underneath the x and negative slope. Underneath the x and negative slope.
-2 to -1, then 2 to 3.
How about 1 to 3? -2 to -1 and 1 to 3. Okay, that sounds good. All right, so now let's write this out and get full credit. F of x is decreasing and concave down on, what are my intervals? -2 to -1 and 1 to 3. There's your first point. Because, what's my reasoning here? F prime of x is, what are the two key words I need to get credit here?
It's both decreasing and negative.
Decreasing and negative. So again, that's also 2 points. One for your answers, one for your reasons. Does anybody have any questions on part A or B?
And this is where, does it matter which order you put like decreasing and negative?
Nah, that should be fine either
Okay.
way. Any questions, guys? A or B? This is a pretty friendly free response. We should be getting most of this correct, I hope. All right, C. We want to know about points of inflection. Where are the points of inflection on this graph? Somebody tell me.
At -1,
Yep.
3, and then 1.
Yes. Okay. So what she just said is correct. And then we got, remember how we have to group it based on the way it turns? So do you see how at -1, and at 3, the graph turns the same way, and then at 1, it turns a different way. So you want to group these based on the way it turns. So it's going to be POI, points of inflection at x equals -1 and 3, because f prime of x changes. How does it change, Caroline, around those points? It changes from what to what?
Decreasing to increasing.
Exactly. Changes from decreasing to increasing. There's a point of inflection at x equals +1 because f prime of x changes from, it's the same thing, but the other way around now, increasing to decreasing. So those are all the explanations, justifications, and answers there. So do we have any questions, confusion, anything on A, B, or C? Very good chance something like that pops up on the AP exam, and you need to know the justifications.
For formatting C, I didn't restate that there was a POI at x equals 2. I just said the first half, and then I put and at x equals 2 because, and then I had this separate explanation. Should you like restate if there are situations where there are multiple reasons for an answer?
Say that one more time.
So I wrote there are points of inflection at x equals -2 and x equals 3 because f prime of x changes from decreasing to increasing, and at x equals 1 because f prime of x changes from increasing to decreasing. Should I like restate that there's a POI at x equals 1 like you did, or can I just connect them with an and?
I think you're fine either way. As long as you have these two and its own reasoning, this one and its own reasoning, I think after that, you'd be fine no matter what.
Okay, thank you.
All right, so we're going to do part D, but I'm going to assume you didn't know how to do this because this is brand new. So not brand new, but pretty new. So does anybody have any thoughts on part D? Because I need to teach this to you. You're not expected to have done that correctly.
The only thing I would guess is the f of 4 and -2 could be like could be chosen as boundaries, as bounds.
Yes, so that's not, yeah, that's correct to an extent, yes. So here's the only thing you got to know. Finding f of 4 and f of -2, first off, it's two different problems. So pretend this is like part D and part E. So two totally different problems. Find f of 4. Okay. Find f of -2. Okay. Two entirely different problems. So they give us a piece of information. This part D is one of the most important pieces I will teach you all year. This opens up the door to all kinds of different math, all kinds of different logic and thought. And it's not hard. You just got to wrap your head around it. They tell me that f of 1 is 3. And I also know that we have the graph of the derivative. So just for a second, tell me here, guys, what do we get if we integrate f prime?
F.
Okay, so I'm going to turn the screen share off for a second. I want to do this a little better. All right, if we integrate f prime, we get f. All right, now let's put some bounds in here. Let's just call them a and b. If we integrate f prime from a to b, that would mean when you get f, it's from those bounds. So does it make sense to say that you would end up with f of b minus f of a?
Yes.
Hopefully everybody's nodding their head. Super, super, super important. So let's recap that rule. The integral from a to b of f prime of x dx is equal to regular f of b minus regular f of a. If you were to look this up, this is called has a real fancy, important sounding name. The Fundamental Theorem of Calculus. If you were to Google that, this is what would pop up. The integral from a to b of f prime of x dx is equal to f of b minus f of a. Super, super, super important. Give me 1 second. Hang on. Go ahead and write that down. I'm sorry, guys. Give me 2 seconds. I'll be right with you. Okay, sorry about that. I'm back. I was teaching you the most important thing of the year and I left you hanging. All right, Fundamental Theorem of Calculus. This should look familiar. If you integrate f prime, we're going to get f. This is just what you've been talking about when I keep saying solve the riddle. It's just solving the riddle with bounds involved. Okay, so let's flash back now to our problem. All right, so we're going to do one thing at a time. So for right now, I'm just finding f of 4. Let's work with that. All right, if I integrate f prime, I get f. And I'm trying to find an answer involving f. So if I integrate f prime, all right, and what am I trying to find? I'm trying to find f of 4. Okay, what do they give me? Do they give me any completed piece of information?
F of 1 is 3.
They give me that. All right, so I'm going to let my bounds be 1 to 4. I'm going to be flashing back and forth a little bit here. Okay, when you do this fundamental theorem of calculus, 99% of the time, and I don't know which one of these bounds are going to be, but one of these bounds, I'm just going to draw arrows. One bound I want, one bound I know. Okay, and it could be the other way around. This could be the one you know, that could be the one you want, could go either way. But when we're doing this fundamental theorem idea, it's going to be, I'm going to integrate the derivative with a bound I know and a bound I want. So you got to have one of them and you got to want to find the other. Okay, so if we apply that, think about what this is going to mean. Come down to here now, back to our problem. What do you get if you integrate f prime? You get f of 4 minus f of 1. Is everybody still good?
Yes.
Okay. Next, the math looks messy. It's actually really easy. Pretend this says the following. A equals B minus C. Pretend that's what you're working with. Which one of these things am I trying to solve for? A, B, or C?
B.
I'm trying to solve for B. So again, I know it looks messy, but just pretend this says A equals B minus C. If I want to solve for B, what am I doing?
Yeah, you isolate it
By doing what?
by subtracting, by moving that C to the other side.
Yeah, okay, there you go. So would that make sense to say that B is equal to C plus A? Are we still on the same page? So if I come down here, I'm going to take this f of 1, I'm tossing it to the other side. So this is f of 1 plus the integral from 1 to 4 of f prime of x dx is equal to f of 4. You guys got to talk to me. Don't just write this down blindly. Are we still on the same page?
Mr. Baker, why didn't you put the values of F4 and F1 like directly here?
Coming in next.
From the
Coming in next. Coming in next. Now, I don't know what f of 4 is. That's going to be the answer to the question. I do not know that answer. However, I do know, let's go back to the problem. I do know that f of 1 is 3. I know that. So over here, I'm going to say f of 1 is 3 plus, I need to get an answer for this, and that's going to give me f of 4. Okay, next. What am I trying to find now, guys? What is this? Describe it to me. What am I trying to find? 3 plus something. What's the something?
F4 negative F. No, that's the same.
The integral of
Okay, the integral from 1 to 4 of f prime of x dx. Tell me in English though, Leela, what does that mean? When I'm finding an integral of f prime, it's either a formula or it's what you're about to tell me.
the area under the curve.
Okay, and I have the graph f prime. So the integral from 1 to 4 of f prime is the area under that curve. But is the area under that curve something nice? Is that like a triangle that I could use?
No.
No. If it was a triangle, cool. I'd go find the area. We're home free. It's not a triangle. That means we're in trouble unless they just go ahead and tell me the answer. So now look at the area that I've highlighted. The area of the regions bounded by the x-axis in the graph of f prime, yada, yada, yada. They tell you the areas. The areas of the regions, -2 to 1 has an area of 9, 1 to 4 has an area of 12. Everybody with me? So the integral from 1 to 4 of f prime of x dx is equal to 12. But what do we need to do to that 12? What can you tell me about that area? Is it above or below the x-axis?
It's
It's
below, so
below.
it's got to be negative.
It's got to be negative. So we're going to make this a negative 12. So the answer to this particular portion of the question is -9 is equal to f of 4. Okay. All right. So that's a lot to take in. So let's recap what we just did. Okay. This problem asked me to find f of 4. And they told me the bound for f of 1. They gave me f of 1. So when we're trying to run this fundamental theorem, and you're going to do this like 20 times on the AP exam, it's going to be the integral of something derived from one of the bounds I know and one of the bounds I want turns into the original function with the bounds plugged in. And then you take this 3-part thing and say, which one of these 3 am I solving for? And in our problem, we were solving for f of 4. So whichever one you're solving for, get rid of the other one, and then you start doing math. F of 1, they give me, This has a graph, and then from that graph, you're either going to do geometry, you're going to do Riemann sums, you're going to just be given the area because it's some bizarre shape that you can't find, and then you got an answer. Thoughts, comments?
Can you go back to the other part of the paper with like the f of a and f of b? Thank
Oh,
you.
the other part of the paper. I think that's the problem. I'm sorry.
Oh, yeah.
Okay, so as you're looking at that on the screen right now, I want you guys to, on your own, tackle part D, the second part. Find f of -2. It's an entirely separate problem. So again, it's got to be from a bound you know to a bound you want. And they give you the bound you know. Always use the one they give you. Can't go wrong there. There's the one they give you. So take that and run with it. Ready, go.
I have a question. So the smaller bound should be placed like the like downward, like, and the, I mean, like it should it be like 1 over 1 and -2, or -2 or and 1?
So the smaller bound always goes on the bottom. The bigger bound always goes on the top.
Yeah, okay, got
Think
it.
of this A and B for bigger.
Yeah, I got it. Thank you.
Mhm. All right, we ready or we need more time?
Ready.
All right, so you look at it, and the key to this is going to really just be doing it enough times that you recognize the situation. So this is all brand new today, but it's called the FTC, the Fundamental Theorem of Calculus. And we want to start by saying the integral of f prime of x dx, and it's going to be a bound we want and a bound we know. The one I know is 1, and the one I want is -2. So we got to make sure we put them in the right order. Big one's on the top. If we integrate that, it's going to give me f of 1 minus f of -2. And again, you just treat this as a equals b minus c. And in this case, I'm solving for c. So I want you guys to keep this as easy as you can. So again, though, think of this as a equals b minus c. So in this problem, I want to solve for, hopefully you guys can see it's c, right? So does it make sense to say, I'm going to move the c to the left, and I'm going to move a to the right? That would give me c equals b minus a. Does anybody have any questions on that logic? So if we do that, it's going to be, this gets added over, it's f of -2 is equal to f of 1 minus the part that's represented by a, which is that whole integral. Any questions there?
Well, shouldn't it be negative f of -2?
I added it over.
Oh, okay.
Good?
Yeah.
Okay, so let
This
me put
is-
this.
Sound like a stupid question, but couldn't you just subtract f of 1 and it would appear on the left side, and then because both sides would be negative, they would cancel?
No, I don't know about that. Now you could subtract. So always just, you see, this is messy. This is easy. So if you wanted to go with what you just said, we could subtract b, and now you've got this that would be a minus b equals -c. Whatever this answer is, then you would have to divide it by -1.
Oh, so then the other thing would turn negative also.
Yeah,
Okay.
to me, I think that just makes, I don't know. I always treat this problem, because this is very easy to get lost in all this math gibberish. This is very easy to follow along with. So if I just always call it, treat it as 3 blocks, A, B, and C, which one am I solving for? And if I solve that puzzle, I can apply it to something that's harder. So I knew I wanted C. So I just know I'm going to toss C on the far left. I'm going to bring A over. I can work that out.
Okay, that makes sense. Thank you.
Sure. All right, so here's what I want. That's the answer. All right, we know f of 3, or I'm sorry, I said it wrong. F of 1 is equal to 3. And then it's going to be 3 minus something. We need to know the something. So what's the something? It's the integral from -2 to 1, the integral from -2 to 1 of f prime. So we want the area under that curve. It's not a good shape. It's not a triangle. It's not Riemann sums. It's nothing I can work with. It means they better give it to me. And if you look in the problem, they do. Yes, Lila.
Why is it 3 and not -3? Because shouldn't it be the negative f of 1 if you're flipping it over to the other side?
No. Hold on. So this doesn't change to f of -1. It's just f of 1.
No, but shouldn't it be negative f of 1 because you're moving it to the other side of the equal sign?
I didn't move it.
The integral has been moved.
Yeah, the integral is the part to move. Hold on, let's go back. So we had, remember, just identify your 3 pieces. Here's A, here's B, here's C. And I want to solve for C. So C is heading to the left, A is heading to the right. This one isn't going anywhere.
Okay, so you don't want to move the one you don't. Wait, why didn't you move f of 1?
Forget the calculus. Solve for B. Or whatever I want. I'm sorry, solve for C. Forget calculus,
Okay,
solve for C.
So you don't want the negative C, that's why you did that?
Yeah, exactly. So all I'm saying is I'm treating this in-depth calculus problem as A equals B minus C, solve for C. So I'm going to toss C on the left and I'm going to bring A to the right.
Okay, that makes more sense.
And then you just take that logic and then apply it to this mess. But you're still literally just calling it A equals B minus C, solve for the thing they tell me to. And then you just move the pieces accordingly.
Okay.
So this is super, super important to treat everything as A equals B minus C, because these get messy and messier, and they're always a mess. So if you just keep it simple and take a breath and say, all right, easy enough, I'm going to move these messy pieces around, and then you'll get your answer.
Okay.
So what's that?
It's going to give us the same answer anyway. I mean,
Let's see. So I got to go back. So there's definitely different ways to get this. I'm just showing you my way. So the next thing we want is we want this integral from -2 to 1. And they tell me from -2 to 1, it's 9. And the other one is 12. 9 and 12. So this one's going to be 9. But since it's underneath, it's going to be a -9. So I'm coming up with 12 for an answer. Does that make sense? Yes, no, maybe?
Yep.
Yeah.
Questions?
If we don't have, some people in the class are going to hate me for this. If we don't have any homework tonight, could you give us a few practice problems of these?
Yeah, I'm going to give you one right now. We're going to make one up.
Okay, thank you.
Yeah, let's do some practice. So I'm not doing anything else today, guys. We're just going to do some practice with this for 20 minutes and we'll call it a day. So this takes lots of practice. So don't be sitting here like, oh my gosh, I didn't understand it all. Yeah, it's the first time you've seen it. That's totally normal, which is one of the biggest reasons I was freaking out that we didn't have enough time to finish calculus, because I was like, there's so many more things I have to teach them. So you'll be fine. Don't worry. You still got 3 months, lots of time. It'll click. But this stuff takes practice. So let's make a problem that looks like this. So give me a second to make something that works here. Okay, so you've got a graph of f. This is the graph of f prime of x. All right, so give me 1 second here and we'll have some more problems. Okay, give me 1 second here. I need to think through this. You can start with A and B while I'm thinking through the rest of this. All right, so now we've got 3 questions. Okay, so you are doing A, B, and C, and then we'll go over it in a few minutes.
Do you think you should specify the interval for f0 or
Say that again.
I mean for finding f0, should you specify the interval for it, like from which interval to which interval or
No, so when you start it, it's just, you're only gonna have so many choices. It's gotta be from a bound you know and a bound I want. So every time, that's your setup. It's gonna be a bound I want and a bound I know.
thank you, that makes sense.
Mhm. Okay, let's see what we got. So first one, we want to know, where is their relative extrema? Your answer should be something to the extent of relative extrema. There is a relative what at 2, guys? A relative max or relative min?
Max.
Max.
Okay, relative max at x equals 2. Because, what's my because? F prime of x changes from positive to negative. Okay. Points of inflection are the turning points of the derivative. So I see 2 of them. Remember, we're talking about x values. So we should be talking about 0 and 3. So POI at x equals 0, at x equals 3. They each have their own explanations. It's because f prime of x changes from, for the first one, increasing to decreasing, and for the second one, because f prime of x changes from, same thing, just the other way around, decreasing to increasing. Okay. All right, new stuff down here. We want to find f of 0. We're given f of 2. So always just remember, what's the problem asking me? It wants me to find something with f. It gave me something with f. I know the graph, the derivative. So this is going to be the integral of f prime of x dx from two different bounds. One that I know, one that I want. Okay. So when you integrate that, it's going to be f of 2 minus f of 0. This is now my a equals b minus c scenario. What am I trying to find? Find f of 0. So that makes sense, hopefully, to say that I'm going to toss this one on the left. This one doesn't move. That one is heading to the right. So now this is f of 0 is equal to f of 2 minus the integral from 0 to 2 f prime of x dx. And now we just go through and we got to do some math. So this is what I'm looking for. F of 2 is equal to 13 minus, all right, hold up. So what are we doing now? 0 to 2 f prime of x dx, integrating it. The last problem we did, they just told me the area. This one didn't tell you that. How do I find the result of that integral?
You would find the area under the curve.
Yeah, we've got a triangle here. We can do this. So this area here, it's a triangle. Half base height, base height is 6. Half of that means that this has an area of 3. So the integral from 0 to 2 of f prime of x dx, if it's a shape you can work with, you use it. So that becomes 3. So f of 0 is equal to 10. Thoughts, comments, questions? How are we doing?
Could you write it like that for an answer choice?
Could I write? This would be all free response. So
that would be like the answer, like all your work.
100%. Yep, you're all good to go. Your work is the justification for part C. Okay. Just takes practice. You will see this a lot though. This train of thought, that type of problem, it will pop up all over the place. We're going to see it a bunch. So just get used to it. We'll keep working with it. I will show you more free response with it. Tomorrow, we're going to do a big free response problem in class on it. But as far as tonight goes, I don't think there's any reason to give you any homework or anything. You've got that map test thing tomorrow. So remember, you got to log on at 8 a.m. and we got to take whatever test that is. It sounds like it's algebra 2-ish. I don't know. We'll find out in the morning. So that's all I got, guys. So tomorrow you'll take the map test. It's at, yeah, it technically starts at 8:30, but I'm just telling everybody 8 because I got to hit like the go button at 8:30. And I'm sure there's going to be 5,000 questions on this tomorrow. So just aim for 8-ish early. Don't show up at 8:29 on me. Come like at least 10, 15 minutes early. So whatever it is we're doing, we can be set up on it. I heard we were going back. Are you going to start doing tutoring in person? I would love to, Josie. I don't know what the rules are. As soon as I know, you'll know. If they let me, I would be more than happy to have all of you guys in my room after school and stuff to be doing this. It would make it way easier if we could do tutoring in person every day. I have no idea what the rules are going to be though regarding school opening up. So I'm waiting to hear just like you guys are.